Hey, in this tutorial we're having a look at section 12.4 on forces that depend on displacement. So if a force acting on a mass is dependent upon displacement, then we say F is equal to F of x. Okay, they give us a range of different ways that we can talk about our acceleration. So we say acceleration is equal to d squared x on dt squared, it's equal to dv on dt, that's equal to dx dt times dv dx, which is really just our chain rule way that we end up with our dv dt. We can say that's equal to v times dv dt. It's also equal to, sorry, that's not dv dt, that's dv dx. Sorry about that. That didn't really make much sense when you said it was equal to just dv dt. Okay, it's also equal to d over half v squared on dv times dv dx, or it's equal to d over half v squared on dx. Okay, and we can also say that our acceleration is equal to our f of x on m. Now that's just our rearrangement of Newton's second law, that's f equals ma. And we also know that, or are told that a half v squared equals 1 on m times the integral of f of x dx. Okay, so that's basically the theory that we've got to work with. Okay, so we'll have a look at our work examples. So I'm going to start at work example 8. Okay, so I've got a particle of mass 3 kilograms. So I'm going to say our m equals 3. Okay, moves at a time t seconds, its displacement is x meters from the fixed origin. The particle is acted upon by a force, okay, our f of x, okay, a force of negative side of 15 minus 6x over x cubed. Okay, and the particle is at rest at a distance 5 meters from the origin. So v equals 0 when x equals 5. Okay, find where else the particle comes to rest. Okay, so we can look at our mass times our acceleration is equal to our f of x. Okay, well we know our m is 3, so we can say 3 times our acceleration is equal to our force, which is negative 15 minus 6x over our x cubed. Okay, so what we can say then, okay, is that our x is equal to our, we're going to divide by our 3, okay, so we're going to get negative outside of 5 minus 2x over x cubed, okay, and we know that when we integrate that, okay, then it's equal to our half v squared, okay, times our integral of our minus 5 outside of our minus, sorry, our minus outside of, sorry, scratch that, a half v squared is equal to our integral of negative outside of 5 minus 2x over our x cubed dx. Okay, from our formula that we had before, because we're already, okay, taking care of our f on m. Okay, we're taking care of that, so we don't need to bring that out. Okay, because we've already got our f of x on m. That's our equation there, so we don't need to bring the m out. Okay, so what we do then is say, well, our a half v squared, okay, is equal to our integral of negative 5x to the negative 3, okay, plus our 2x to the negative 2, okay, dx. Okay, just rearranging our equation here. So it means that we've got a half v squared, okay, is equal to 5 on 2x to the negative 2, take 2x to the negative 1 plus c. Okay, so we can write that a bit nicer and say that we've got our a half v squared equals 5 on 2x squared, okay, minus 2 on x plus c. Now we know that v equals 0 when x equals 0. Okay, so when we look at that, okay, well, our v equals 0, so this bit's 0. Okay, equals 5 on 2 outside of 5 squared, take 2 on 5 plus c. Okay, so we find then, okay, when we rearrange that, we get c equals 3 on 10. Okay, that means that we get a half v squared equals 5 on 2x squared minus 2 on x plus 3 on 10. Okay, so what we do is make all our denominators the same, bring it together. So we say a half v squared is equal to 25 minus 20x, okay, plus 3x squared all over 10x squared. Okay, and what we can do is we can multiply by our 2, okay, which is going to just cancel out with our 10 here. Okay, and we can factorise our top line and say that we've got v squared, okay, equals to a 3x minus 5 outside of x minus 5. And as I said, we times by 2 is going to cancel with our 10 and make it 5x squared. Okay, so that means, okay, then what we can say is that our v, okay, is equal to, okay, 1 on, now when we take the square root of x squared, that becomes the modulus of x. Okay, I'm going to bring that out at the front to start off with and say that we've got the square root of 3x minus 5, x take 5, okay, over 5. Okay, so bring that 1 on x squared out the front, okay, if you like, okay, and then taking the square root of it so we get our modulus. Okay, so we're getting there, okay, because we've got to find where else our particle comes to rest. Okay, so if v equals 0, okay, then what we can really say is that we need this part to equal 0. Okay, so our 3x minus 5 equals 0, okay, or our x minus 5 equals 0. Okay, therefore x equals 5 or x equals 5 on 3. Okay, we were given when x equals 5, we were told that in the question because we said the particle is at rest at a distance of 5 metres from the origin, so we've used that one. Okay, find where else the particle comes to rest. Well, it comes to rest at 5 on 3 metres from the origin. Okay, and we'll finish that one off. Okay, so we're going to have a look at work example 9 now. Okay, so a body is moving in a straight line. Its velocity v meters per second is given by v equals the square root of 9 minus 4x squared. Okay, when it is x meters from the origin at time t seconds. Show that the acceleration, okay, is given by a equals minus 4x. Okay, well, what we can say is our v equals our 9 minus 4x squared to the power of a half. Okay, so we can say our dv dx, okay, is equal to our half, okay, times by our derivative of what's in the brackets, which is negative 8x, okay, times by what we've got in our brackets, 9 minus 4x squared to the power of negative a half. Okay, so that's just using our chain rule. Okay, we can simplify that, so we've got a half times 8 is going to be obviously 4, so it'll be negative 4x, and we go over, because we're negative power, the square root of 9 minus 4x squared. Okay, now our acceleration, we know, okay, one of our identities for acceleration is that v times dv dx. Okay, so we know what our v is, so we've got to multiply these together. Okay, so our a is going to be the square root of 9 minus 4x squared times by our minus 4x over the square root of 9 minus 4x squared. Well, they're going to cancel out, and a is going to equal minus 4x as required. Okay, so no real dramas with that question. Hopefully you don't get hung up on questions like that too much. And our last worked example for this section, okay, is worked example 10. So a body of mass 5 kilograms. Those are m equals 5. Okay, it moves in a straight line and is retarded by a force of 20x newtons. So that means our f of x equals minus 20x, because we're opposing the force of the motion, where x is its displacement in meters from a fixed origin. Initially the body is 1 meters from the origin, so we can say when t equals 0, okay, x equals 1, and the initial velocity of the body is 2 meters a second. So t equals 0, v equals 2. Express x in terms of t, where t is time in seconds. So again, we know that our mass times our acceleration, okay, is equal to our f of x. Okay, so we know that our m is 5 and our f is that. So we get our 5 times our acceleration is equal to negative 20x. Okay, well our acceleration then, okay, is equal to our minus 4x. Okay, and we know that when we integrate that, we can say that our half v squared, okay, equals our integral on negative 4x dx. Again, we don't have our 1 on m out the front because we're already taking care of that in here. Okay, when we divide it by our 5, okay, then we've already taken care of it and we've simplified it, so that's been no dramas at all. So we're taking care of that. So we can say, well, our half v squared, okay, is equal to minus 2x squared plus c1. Okay, initially when t equals 0, okay, our v equals 2 and x equals 1. Okay, so we need to use that to work out our c value. So we've got a half times 2 squared equals minus 2 times our x, which is 1 squared plus c1. Okay, so we're going to get then that 2 equals minus 2 plus c1, so c1 will equal 4. So then our equation becomes a half v squared equals minus 2x squared, okay, plus 4. Okay, so we're not going too badly there. Okay, we can keep simplifying this and say, well, v squared is equal to, well, we've got times by 2, okay, and we're going to make it 8 minus 4x squared. Okay, so v is going to equal plus or minus the square root of our 8 minus 4x squared, which we can say is plus or minus 2, because if we bring out 4 as a common factor from this and bring that out as 2, the square root of 2 minus x squared. Okay, don't forget that our v is also equal to our dx dt. Okay, so our dt dx is equal to 1 over our v, which is 1 over our 2 times our square root of 2, so minus x squared. Okay, now we don't do the negative, okay, because we know that we've really got to be positive with our displacement. Okay, so that means that our t equal, well, we bring a half out for a start, a half, so of our integral 1 over the square root of 2 minus x squared dx. Okay, so we say, well, t equals a half times the inverse sine of our x on root 2. Okay, plus of course our c2. Okay, but we know when t equals 0, okay, v equals 2 and x equals 1. Okay, so when sub in our x equals 1, okay, and our t equals 0, so we say 0 equals our half times the inverse sine, okay, of our 1 on root 2, okay, plus c2. Okay, so we find that c2, okay, is equal to negative pi on 8. Okay, just by subbing in or equating what that is. Okay, so that means that our t equals our half times the inverse sine, okay, of x on root 2, okay, minus pi on 8, that value for c that we just found. Okay, so we can rearrange this a little bit, okay, because we want to make x the subject. Okay, so we're going to add on pi on 8 and times by 2, so we can really say, well, our inverse sine of x on root 2, okay, is equal to 2t plus pi on 4. Okay, so to get rid of our inverse sine, we take the sine of both sides and say we've got x on root 2 is equal to sine of our 2t plus pi on 4. Okay, I'm just going to come up here and we get our x equals, what they're doing here is we've got x on our root 2. Okay, so we're using some of our formulas that we know, and we're saying that our sine of 2t, okay, cos of pi on 4, okay, plus cos of 2t, okay, sine of pi on 4. Okay, so we've got that. I'm not sure why you'd really worry about doing this too much, okay, but they decide to. I suppose we can simplify it. It does simplify down pretty nicely, but still it seems like a little bit of a waste of time when we could just multiply by root 2. However, we'll keep soldiering on, okay, and we get, well, x on root 2, okay, is equal to, well, cos of pi on 4 is 1 on root 2 sine of 2t, okay, plus, well, sine of pi on 4 is also 1 on root 2, okay, of cos of 2t. Okay, we multiply by our root 2, okay, cancelling out those, so we get x is sine of 2t plus cos of 2t, okay, and therefore we have our x in terms of t, okay, which is all we need to do for this worked example. So yes, some of these are quite long, but again, like what we've done in the previous two tutorials, okay, often the process is quite similar. So hopefully we won't have too much trouble when we get to doing these questions.